Hi, I'm Divya from Department of ECE, Tech Multitech Dr.Rangarajan, Sakunthala Engineering College. Now I'm going to present a topic on synchronous sequential logic circuit. In synchronous sequential logic circuits, handheld devices, cell phones, and navigation receiver, personal computer, digital cameras, the ability to send, receive, store, retrieve, and process information represented in a binary format. These devices, dependent on electronic components that can store information, have memory. This is the block diagram of sequential circuit. In the sequential circuit is a digital logic circuit that uses memory elements to store information and produce output based on current and past output. How the sequential circuit is working on? The sequential circuit have combinational circuit and feedback output or fed back into the circuit as input. This is the detailed about sequential circuit. In sequential circuit consists of feedback and storage element. In storage element is used to store the binary information, and this information is considered as a store binary 0 and 1s. Okay, these external inputs also determine the conditions for changing the state in the storage elements. The sequential circuit is a function of the input and present state of the storage elements. The next state of the storage element is the external inputs and the present state. The output of the combinational logic depends only on the present value of the inputs. We have two types of sequential circuit: synchronous sequential circuit and asynchronous sequential circuit. In synchronous sequential circuit, use clock pulse only, and asynchronous sequential circuit do not use clock pulses. And in synchronous sequential circuits, store the output in the flip-flop, and asynchronous sequential circuit change the state when the input variable will be changed. The synchronous sequential circuit, the output with the previous negative and clock edges. And in synchronous sequential circuit, system whose behavior, knowledge of its signals and discrete instant of time. A clock signal is commonly denoted by the identifier clock. The clock pulses are distributed throughout the system. The storage element are affected only with the arrival of each clock pulse. The clocked sequential circuits are used to control the storage element and the type of most frequently used in the practice. The sequential circuit resulting the stored value in the occurrence of the clock pulses. In asynchronous sequential circuit, only depend upon the input signals and the time in which the input change, the output also will be the change. The asynchronous sequential circuit also used for the time delay devices. The storage capability of the time delay signal to propagate through the devices. The flip-flop. Flip-flop is a 2-bit of store information, zeros and ones. The flip-flop is capable of memory is called as memory devices. The output of the flip-flop is either 0 and 1. The sequential circuit uses flip-flops to store many bits as we needed. This is the synchronous sequential circuit. In the synchronous sequential circuit, the combinational circuits are used and the storage element is instead of flip-flop are used. If a clock pulses are used for the synchronous sequential circuit, in this circuit, the memory element to store the information and produce output based on current and past inputs. In synchronous sequential logic circuit, the value of the flip-flop and clock pulses is inputs value presently stored in the flip-flop. When the clock pulses is appeared at the output of the circuit. This is the synchronous sequential circuit. The change in the state of the flip-flop is initiated only by the clock pulses. The value from the clock pulses changes from 0 to 1. This is the timing diagram of the clock pulses. In the flip-flop, storing all the flip-flops, storing one bit of information, Other types of flip-flops are also available. SR flip-flop, D flip-flop, JK flip-flop and T flip-flop. The set all the flip-flops. This is the SR flip-flop. SR flip-flop is the most common flip-flop in digital system. S is the set and R is the reset. This is a circuit diagram of the flip-flop. S and R two inputs are used and Q and Q bar the two outputs are used. The S input is feedback to the Q bar and R input is feedback to the Q. This is the circuit of the SR flip-flop. This is the truth table of the SR flip-flop. If I am giving the input to the 0 0, the output will be get 0 and the inverse of feedback to 1. If I am giving the input to the 0 1, the output will be get 1. If I give the input to 1 1, the infinity will be get. This is the D flip-flop. T flip-flop, we have used only one input and one clock pulses. It is Q of t represent the present state and Q of t plus 1 is the next state. This is the D flip-flop truth table. If I give the input to 0, the output will be reset. If I give the input to 1, the output will set. Whatever, if I give the input, the output will be reflect. This is the characteristics table of the T flip-flop. This is JK flip-flop. Then in the JK flip-flop is similar to the SR flip-flop. The two inputs are used and also connected with the D flip-flop and the clock pulses are used in the JK flip-flop. In JK flip-flop, if J is equal to 1 and K is equal to 1, the output will get the negative edge clock set to the output 1. When the J is equal to 0 and K is equal to 1, the next clock edge is at the output to 0. When J is equal to K is equal to 1, the next clock edge complements the output. The J K is equal to 0, the clock edges leave the output of the unchanged. This is the truth table of the JK flip-flop. This is the, if I give the input to the 0 0, the output will not change. The 0 will be present in the output. If I give the input to 0 1, the output will be reset. The 0 will be get. If I give the input to the 1 0, the output will be get set condition. If I give the 1 1, the next state of the JK flip-flop will be the complement of the 0. This is the characteristic equation of the JK flip-flop. This is the next state of the Q of t plus 1 is the next state and the present state J is the input, Q bar is the output and K bar and Q. This is the characteristic equation of the JK flip-flop. And one more flip-flop is T flip-flop. We call it as toggle flip-flop. It is similar to the JK flip-flop. Only one JK flip-flop and toggle to the K flip-flop. Clock pulses are applied. If t is equal to 0, the clock does not change the output. If t is equal to 1, the clock edge complements the output. Next, this is the T flip-flop. We use the t is equal to 0 and there is no change in the output. T is equal to 1, the output of the complements. This is the characteristic tables of the T flip-flop. If I give the input to 0, the output will not be changed. The same output will be get 0. If I give the input to 1, the output will be the complement. The characteristic equation is, this is the next state equation, P exclusive Q. Thank you.